Subject code 18CS2011, design and analysis of algorithms, experiment number 1, implementation of fractional knapsack problem. In this video we are going to see how to implement a fractional knapsack problem using greedy approach. So a fractional knapsack problem, first thing we will be having some n number of items, and we'll be having their weights, profits, and after that we have to calculate the profit to weight ratio for each item, and we have to sort those ratios in descending order, and according to the sorted list we have to add the profit to a separate variable, and we have to add the weight of each item into the back capacity. So initially we will be having a fixed back capacity, and one thing we have to check here is the items inside the back, the weight of the items inside the knapsack doesn't overflow the back capacity. So in that way we will be calculating the total possible profit out of the n items. So this is the knapsack class, and for each item we will be having the weight and its profit and its profit to weight ratio. So these are the class variables. So for each item we will be creating an object, and for each object we will be having weight, its profit and its ratio. So first thing we will start from here. So here we are taking the input from the user, number of items and the back capacity, and this value is nothing but to take the input in proper way. So here we have a for loop for in range of number of items. That means we are taking the input for each the weight and profit for each object. So after that, if the length of data is less than 2, that means if the weight is given and the profit is not given, so we'll be keep on iterating in this value, so until the correct input is given by the user. So after we get the input, we are see here each object equal to all data is nothing but an empty list, and we are adding the int of data of 0. That means the weight. The first knapsack of this is the object of the class which we have defined above, and these are the parameters, and int of data of 0, that is nothing but the weight, and int of data of 1, that is nothing but the profit, and here is the profit to weight ratio. So those are the things we have to pass, we have to enter into this, we have to append into this empty list, and after that in this while loop itself we are calculating the total weight of the each items. So why we are doing like this is, if the total weight of all the items is less than the back capacity, simply we can add all the items in back capacity and calculate the display the profit as total, as the sum of the profits of all the items. That's what we are doing here. If total weight is less than back capacity, we are printing total profit equal to profit sum. That means the profit of each item. So or else if not, we have to take a fraction of the item which is left. So that's to do that, first thing we have another empty list unsorted, and after that we are just adding the ratios of each item into that list, and after that we are calling the sorting algorithm, which is nothing but the merge sort algorithm, which takes this n log n time to finish. And after that, after calling this merge sort algorithm is defined in inside the class itself. So this is the class method, and that returns the profit to weight ratios in descending order. Okay, so after that again this list ascending contains the the profit to weight ratios in ascending order. All data is nothing but it contains the object, the items in form of objects, each object. So I dot ratio means it's all the ratios of each item will be appended into this ascending list, empty list. So after that we are defining a variable called total profit to calculate the total possible profit, and after that this is the index equal to -1, and we'll see it later. And we have a loop here. So all data of, and now this loop, in this loop we have first one we will see here sorted of j. That means the greatest ratio of all the ratios which are being sorted in descending order. The greatest of that one, we are taking the index of that one in the ascending. Ascending is the list that contains the ratios in ascending order, right? So that one, and all data of that means the object. So if that weight is less than the or equal to the back capacity, so that we are adding the profit of that item, so this item, and profit to this total profit variable, and after that we are decrementing the back capacity by the weight of that item. So after that we are we are taking the j variable into the index variable. So why this means, if the loop has been executed for each item in the list, so this j will index will be the length of the sorted minus 1, right? So if that is true, then we'll print the total profit. We will not be taking any fraction of the item. So if not, we have to take the fraction of the item. So for if the weight to be added is 20 and the back capacity is not, if it is less than 20, so we'll take the fraction of that back capacity itself. So that's what we have done here, and after that we are printing total profit. So this is how we have solved the fractional knapsack problem. Now we'll run this and check if it's working perfectly. For example, we'll give 3 and capacity let it be 45, and first thing, let weight be 18 and profit 12 and weight be 25 and profit 31, it be 4 26 and profit be 30. So something called total possible profit is, out of these items which we can get, the total possible profit is 54.076. So I hope the output is correct and the program has been executed successfully. Thank you.